one area. I can say that it's really important to understand that event correlation requires more than just intrusion detection system data. You need to get data from routers, from switches. You need to get data from firewalls. You need to get data from individual hosts. You need to get data from things like web servers and FTP servers if you want really good correlation. I will say also that the quality of rules that you have makes a huge difference. I've looked at some, freeware products and things like this and looked at the quality of their rules, and I'm confident that they would not achieve the kinds of benchmark scores that a system that has much more sophisticated rules would be able to produce. And let me just say that if you're looking for what might happen in the future, I think number one, all of security is moving up to layer 7 of the OSI model. All of security there. We need to understand what happens at the application layer better. Event correlation is no exception. If we don't really understand what's happening there, a lot of times people can masquerade their activity at lower layers, like layer 2 and 3. And I know some of you are Unix people and you just want 4 layers, and that's fine. But we have to deal with 7 layers if we deal with the totality of operating systems out there, because some operating systems have, I won't say which, have superfluous layers. And then also, you need more sophisticated alert fusion. And that is a problem because if you don't want to be annoyed by alert after alert after alert if there's only really one set of related attacks going on. And I don't think the models we have for alert fusion are nearly good enough. And that's something that I, as a CTO of this company, are working on very hard. And then also, I think that one of the futures of this whole area is high-speed data mining. Because, we do as much as we can in near real time, but the fact is there's enough slow and gradual attacks out there to where we're going to miss some stuff that if we now also did data mining, we could probably pick these attacks up. Let me tell you that the worst attack I saw at UC Berkeley happened about 3 years ago, and we did not discover this attack for about 2.5 months after it happened. And the only reason we discovered this attack was we were able to go back to our archive of data, and we were able to use the fgrep command and use it. So we piped one fgrep to another and found combination of events that told us, yeah, somebody broke in. And sure enough, it was actually a whole gang of attackers who had broken in from Brazil. They called themselves the boys from Brazil. And also, the one last point I would try to make is that advances in event correlation really do show that there is a symbiosis between the kind of basic research that's being done and published in journals out there, and also the applied research that is being done by companies like myself. And that's a good thing to realize, because it means that if you do end up out in industry and you are charged with a creative function as far as being a computer scientist, that there is some help in underlying concepts out there in some of the basic research that has occurred. Thanks much for your attention. And
yeah, we have time for.
We do have time for a few.
Press your button if you have a question.
You kept using the word correlation, but it seems kind of. When I look at this, I see more like causal inference or path analysis, or maybe even using something like structured equation modeling at the end of the day, because it's kind of like event A follows event B follows event C. So, how good is correlation at detecting that? Would it be different? Would it be better to use causal inference or something along the lines of path analysis? I guess that's my first question, and then the second question is. A lot of people are focusing on extrusion detection. What's your point of view on that in the larger scale of things?
Well, you have to explain what you meant by your second question, but to answer your first question, unfortunately, sometimes terms stick that aren't the best terms in the world. And a good example is the term intrusion detection in the first place. That's a terrible term. But unfortunately, the person who thought of it was the seminal thinker in the field. His name was Richard Anderson. He, in 1980, put a seminal paper through to the government, and the term intrusion detection stuck. Why is intrusion detection an awful term? Because much more than intrusions happen, right? Denial of service attacks are the most common kind of attack on the internet. So correlation probably has unfortunately fallen in the same problem, and you're 100% right. And I could see things like Petri nets and things like this being very useful in this kind of analysis too. I agree with you. Now, you need to explain your second question if you don't mind.
I guess you answered
Accidentally? I like those. Thank you. Anything else? Any of you inspired to go into this area? It really is fun. I have to tell you, if you want to have fun on your job, this is a fun thing to do. And it's the kind of thing where you lose track of time. If you can do that on a job, it's worth something. Plus the beach is only 3 miles away. Yeah.
So you give various numbers of performance. So what kind of data do you use to evaluate the product?
What kind of data do we use?
Where do you get the data?
Well, usually from Bayesian detection models.
I mean the network data that you use to test the different.
Okay, so what you really have is I'm going to speak a little bit. Well, I'm going to speak mathematically. What you functionally have is nominal data, right? You have either 1, we had an alert, or 0, no, we didn't have an alert, right?
I mean whether you generate your own traffic or do you collect traffic out in the wild?
Okay, how do we test it? We go and get a tool like Encore Technologies has a tool that just launches its own set of attacks, and it knows what to do if it roots the system and where to go from there, and we let a tool like that go. We also have a tool called the Port Replicator, which launches enough of attack to trigger intrusion detection systems and firewalls without going through the attack all the way. We use a variety of tools. We also use black box testing.
But in order to do the Bayesian evaluation correctly, you need to know what percentage of the data of the traffic are actually attacked.
That's right.
But how do you know that in real life?
Because we launch discrete series of attacks. Okay, let's launch 20 attacks. They will be this one, this one, this one, this one, this one, this one, this one. Then we see what the event correlator picked up. Okay? And see what it didn't pick up, and then on that basis can calculate correct detection rates and false alarm rates.
Another way, so how many rules do you have in your
How many what?
rules, number of rules?
How many rules? Well, we use very, very detailed high-level rules, and we have about 75 of them. Yeah. Yeah. About 75 seems to do the trick for what we need to do, but we're always evolving new rules. I'm working on a new set right now, as a matter of fact, so we'll probably be, by our next release, up to about 80. But our most critical rules came in about our first 2 dozen. By our first 2 dozen, I think we captured the set of things that would pick up most incidents. And by the way, sometimes it's really interesting how this thing works. I never thought I'd be getting into anything like this before I did it. But one of the most interesting things is sometimes, let's say, rule number 3 will fire, but for the same incident, rule 17 and 60 will fire. And we think that's okay. Because more than one rule's logic was fulfilled, it's probably better that you have all those rules fire than you'd had no rules fire. But there are some kinds of incidents that will trigger more than one rule's logic, and sometimes it's a little confusing to the novice monitor. Anything else? Yeah.
Is anomaly-based intrusion detection still as impractical as when I last checked?
Is anomaly-based? Well, first of all, let me explain what anomaly-based intrusion detection is, just in case somebody's not heard the term. You build up certain profiles. You can build up certain profiles of your behavior. Like I get to work early. I'm usually work by 7 in the morning, believe it or not. I know it sounds awful. And I usually leave work by about 6 o'clock at night. So we can build up a profile, my usage pattern, such that if there's activity on my account at 2:45 in the morning, that would be so far out in terms of standard deviation, statistical standard deviation, that we would fire a report. Yes, profile or anomaly-based intrusion detection has its problems. It's used heavily still by the CIA and the FBI and in a few other very sensitive contexts. But in general, the problem is too many false alarms. We just get too many false alarms, and nobody seems to know how to lower those false alarms down to a lower. I did a project for an unnamed agency of the government after I left Purdue in 2001, in which they were trying to get a behavioral analysis going. And when we benchmarked the tool, same problem. False alarm rate of 9%. That's unacceptably high. You cannot have false alarms around that rate. So as far as building profiles of user behavior and then seeing, and also of network behavior. And network behavior profiling is a little more efficient, because if you, let's say we have so many gigabits of traffic that go over this network segment, but now it jumps up to 5 times that, well,